Hello friends, now today I am going to discuss in the just previous video I have already completed what is the difference between the supervised and unsupervised machine learning, and I also described like a unsupervised machine learning. But just we are doing just unsupervised learning. It's we discussed clusters, and clusters means hierarchical methods is the one of the methods to the clusters. So the hierarchical methods, it's a very useful and to the sort the clusters in the natural hierarchical structures. So there are two hierarchical clustering methods. One is agglomerative clusterings and another is like a divisive clusterings. So these two methods is a really important, and let's do here and try to understand how do we solve this one. So it's a very important, and so I need to take a one whiteboard, and then I am going to describe here hierarchical methods. So it's a you go the new board. It's a don't need here. Let's see in the hierarchical I am discussing here. Hierarchical method. So hierarchical method is useful to sort the clusters in the natural hierarchical structures. So it's a two hierarchical clustering methods. There are the two, and I am putting here these two parts. One is the agglomerative clusterings, and another is like a divisive clusterings, right? So agglomerative clusterings means like a bottom up, where it's a bottom up, and another is the start with the n clusters and start with n clusters, n tiers. And divisive clusters means the top down. It's a like a top down, and we start from the single clusters and start from it's a single cluster. So that include all records and divides it into the n clusters. Like agglomerative clusterings is the many use the hierarchical methods, and start with the n cluster progressively. It's a try to understand. So let's see, the divisive clusters is the start from clusters that includes all samples, which is repeatedly divides into the small clusters until the one sample remains in the clusters. So how does agglomerative clusterings work? So it's a start with the single record clusters. Pairs of similar clusters are merged until all clusters have been merged into one big clusters contain all records. And what is a agglomerative clustering algorithms? So let's start with the n clusters is the first part, and merge the two closest records clusters as one cluster, and two closest clusters are merged in every steps. So this refers to adding single records to the existing clusters or combine the two existing clusters. So agglomerative hierarchical clustering starts each objects of an individual atomic clusters, each object so many way. If I am going to the discuss agglomerative. So let's say one is the y-axis and x-axis. So let's start with the 2, 4 and 6. This one is the x1 and it will start from the 0, and now here is the 1, 2 and dot 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 till 3, 4, 5 and 6. It's a x2 dependent here, and one plot here like a it's a it's a B. There are two plots, and it's a D, and it's a E, and it's a F, and it's a C. So these are the plotted. And similarly, if you go in the second diagram, like as it is 2, 4 and 6, this one is the x1, and it will 1, it's a 2, it's a 3, it's a 4, it's a 5, it's a 6, and look here A, and it's a B here, it's a A here. Now go D, and it's a E here, and F is here. So these are in the circles way we can put here, because these are the closest where, so we are taking as a, this one is the close, so we will take as it. Similarly, this process will go, and it is constructing like a Venn diagrams. So hierarchical clustering analysis is useful to sort clusters in natural hierarchical structures. So about the hierarchical constructions, this is the unsupervised learning algorithms, and they are only the x variables, so also called the agglomerative clusters. Nearest items are gathered to form ever growing clusters, so can be visualized resembling an inverted tree like a structure called the dendrograms. Purpose of the hierarchical clusters like a clusters the observations into a given numbers of clusters. So different clustering algorithms is introduced, and this time around we are discussing only the hierarchical cluster. So it's a really each and everything has a pro and cons. So intuitive interpretations of the result, dendrogram that can be further processed to produce a desired number of clusters, and cons a bit more times consuming that k-means. So hierarchical clusterings like first we can construct like the group together nearest observations to get a small clusters, and group the nearest clusters together to uh, form a large clusters, and repeat from these steps until all observations are grouped together into a single clusters, and then cut dendrograms to appropriate heights such that we get a desired numbers of clusters. So it's a single linkage is the head. There are the another we can measure the inter clusters distance like a single linkage. If two clusters are a distance, and we can connect to one another, complete linkage, average linkage. So let's discuss algorithms and try to understand how it works. So let's see hierarchical cluster. So first we need to import some basic library like a from sklearn dot. We need to take a data sets. So we will create, and we try to import the some library. So from sklearn learn dot datasets dot data sets import make underscore blocks make underscore blobs and make underscore moons, comma make underscore moons. So let's see, it's I am importing this library, and I think it's a it's a from sklearn datasets. Let's check, and then I want to import another library, like we want to the plot these variables. So I need to the import like some other library like a matplotlib. Just I am already discussed is class. So import matplotlib dot pyplot as plt. I hope it has been imported and now it's alright. Let's create a variable. So just I am taking as a x1, it's a one of these variable and it's a label one. It's a label one should be equal to, we have taken like a make blobs, so you can use the control C and make blobs and like a create a n underscore samples. It's a n underscore samples like this and need to create 100 blocks. So it's a not 100, keep here 200, doesn't matter, and comma after n underscore feature. So you can see here n underscore feature here, like we can put integers v. So n underscore feature control C v, don't put here the integers, okay, and then we need to write a center. It's a centers like a will equal to 2, yeah, any we can write here center v will equal to like anything, and another cluster underscore std has been given here, control C, and I can write here it's a cluster std will equal to, you can put here like 5 clusters, and then random step because you do not want to change my variable else, so we can use the random state. I want to fix my variable which will equal to like anything. So I hope we have created. Now I want to plot this data like a plt dot scatter. So let's see here, it's running and not. I have gotten some problem. It's a random, not a random. So it's a random state. Now it's alright. Okay. So let's see. Just I am going to the plot. So plt dot scatter scatter and parenthesis. Let's start x1 slash, it's a 0 and next x1 slash 1 x1 it's a slice it's a 1 and c will equal to level and alpha will equal to, you can put here LA, so put here level 1 because LABEL should be right here. It's a level LABEL level 1, and then I am going to put alpha equal to 0.7. level L A is now it's alright. Level 1 y yes, I am getting some problem. Look here. PLT scatter x1 slice 0 x1 and its slice 1 c will equal to its level alpha will equal to, so why I am getting here is some problem. One minute. PLT SCA, it's a S is known. So don't worry, so x and y must be the same size, so I think it's a running and alpha should be equal to, now c will equal to, c will equal to L A B E L level 1 so level 1. So x0 and x1 and n features center is a 2, clusters std is a 5. Now the random state has been given something. Okay, let's see. Sometimes I am getting it's a problem, so it's a level 1, it's not working. Something is not working. It's a okay, so let's write here PLT and dot title tells it will start from like a data sets 1, it's original, data sets like a 1 and it's a original, so you can write here this one it's a original and second PLT dot show. I think PLT dot so let's see, and it's working properly and not, I think just again I have getting some problem, so I need to see. It's wait a 1 minute, just I am taking here, it's has been created and I am going to change here, so 1 2 3 and then I am going to write here check spelling plt dot scatter. Now set the axes here, and x should be equal to x as a capital I have taken, so x1 will equal to slice, it's a 0, and x1 will equal to slice and it's a 1. After the brackets, now the c will equal to label 1 and alpha will equal to 0.7. So yeah, it's a data hasn't been created like this. So something a problem in this matter, so don't worry, just I have already done hierarchical, so I think it should be created till here. So let's see. Stop it. Data has been done, and then we try to create a problem. So x and y must be the same size. So did I write the x and y should be must the same size. Origin it's a 0, and now you can put here it's a 1. So it's a 0 to 1, and now it has been created like a 0 to 1 blocks. So I think just it's just some basic problem, so don't worry. I have already done one project, so let's see this project hierarchical and k-mean clustering, so you can understand how do we solve this k-mean clustering. So sometimes I am getting a same, you have also getting the same problem too, so don't worry, don't try to your hierarchical clustering. So it's a big data. Yeah, let's do here. Just I have done the same here from scalar, and it's a same, just x label, and I have written the I have plotted like this way, and after that we will create the another levels like the x2 level 2 and make a moons like n samples noise here random, and plt dot scatters x2 like it's a similar, but here I am taking a x2 variable. So it's another scattered plot like a variable 2. Then after that just I am going to from scalar dot clusters import agglomerative clusterings and import numpy as a np, import a pandas as a pt, and x1 has been create an array, and then after agglo means agglomerative clusterings, n clusters will equal to 2, so agglo dot fit method I have applied here. Then color has been discussed here like this one, a red like represent as a 0 and 1 as a green, and then plot. So it's a agglomeratives has been plotted, and after that agglomerative clusterings like n clusters will equal to 2, so the agglo dot fit x2, and it's the same way, just it's a second variable has been, and after in the means from the sci pi dot cluster hierarchical, import the linkage and dendrogram f clusters. So my linkage like a x1 and the method like a single I am applying here, plt figure and figure size I have given, dendrograms my linkage plt dot. So we have created like a dendrogram like this way. So each and every nearest distance has been created. After that, the label the clusters the my linkage, and I am using here the criteria like a distance. So we can plot here the distance. It's a method of the distance like a x2 with the x2 variable, and similarly we will take another value, and we are taking a data from like a data sets iris data and import a math plot and this one. So iris data has been seen like this, and then just I have created the data like only the converted into the we need to the plot here the only the two columns. So one is the petal length and petal width, and then I try to plot like from SQL cluster import agglomerative clusters and leakage the complete average and watts. So for idx I in the enumerate leakage and plt figure idx and HIER agglomerative clusters n clusters affinity Euclidean linkage and HIER dot fit the variable like a data ilog like a 2 and 4 and scatter this plot. So we have plotted because all these value like a set versi colors to serve, and these three colors have been plotted so we can understand. And then from SCI pi dot clusters import the hierarchical dot linkage iris data like a complete measures. So we will see here it's a all has been plotted. And now similarly if you want to the single plotted, so it's a also possible to the it's a hierarchical dot linkage iris data ilog dot like a single. So these methods we have already. So it's a good way to understand. I hope it will be helpful for the anyone and someone. So next time I will discuss the more about something. So thank you very much today.